Fantastic to see so many people here. We may have to jig the timetable slightly, but hopefully not too much, depending on people's arrivals time. I'm Mark, I'm at the Royal Society of Biology, and I'm just doing a little bit of emceeing today, and you've got details in your packs, and you'd have seen online, of all our speakers today, so I'm not going to run through everyone's CV. There are no fire drills today in terms of the housekeeping. I think you know the bathrooms are down here and down there. So if there is a fire of any description, you'll follow the staff, please, and so on. If you want to use Twitter, on here you've got hashtag linksday23, and if you can set your phones to silent, that'd be much appreciated during the course of the morning. This Links Day is the 35th, and we will hear from the founding father of Links Day at the very end of the morning, and I'll leave him to tell you a little bit more about that. It's a fantastic opportunity to bring together the whole of the science and engineering mathematical community with parliamentarians to talk about issues of the day. And what more important subject could we have than science and economic development, especially in light of the potential election coming up in the not too distant future. So lots to talk about. If you do have a question, and some speakers are taking questions, some aren't, but if you do have a question, there are some microphones. And this is a good opportunity to welcome any of you who are watching online today. We have online participants. And the microphones are probably most important for those people, because although we may be able to hear in this room, if you don't use them, then it will be difficult for those people online. And obviously, if you can say who you are and your affiliation, that would be really helpful. Thank you very much. I'm here just bringing this thing together with my team at the Society. It's really important to stress that this is not a Royal Society of Biology event. It's on behalf of the whole science, technology and engineering community. You'll see the logos up here of some organisations who are very actively engaged, but actually it goes much wider than that. And so thank you to all of them for your support and engagement in making this possible today. We've got 3 members of Parliament speaking, and I guess 2010 must have been a really good year, because I think all 3 of you were elected for the first time in 2010. So I'll stop there. A great pleasure to introduce Stephen Metcalfe, who's the member of South Basildon and East Thurrock, and he's our sponsor for today and has been a great supporter of this event over many years, and indeed for the science and technology community more generally. So Stephen, thank you very much.
Mark, thank you very much indeed. Well, good morning, everybody. Welcome to this sweltering hot room in Portcullis House. As Mark said, this is the 35th anniversary, and it's great to be doing these things again back in person. As Mark said, I'm Stephen Metcalfe. I'm Member of Parliament for South Basildon and East Thurrock, which is sort of 30 miles east of here. But I think the reason that I get invited to come and take part in this each year and potentially sponsor the room is that I also chair the Parliamentary and Scientific Committee, which is the oldest all-party parliamentary group. It's the group that looks after and takes an interest in science, and it's very different to the Science and Technology Committee or the Science and Innovation and Technology Committee, as it is now known. And I have to give apologies from the chair, Greg Clark. He apologises he can't be with us to say a few words, but he is here in spirit. The Parliamentary and Scientific Committee, which, as I say, I chair and have done for the last 8 years, was established in 1939, for those of you who haven't heard me say this before, to try and bring Parliament and science together. At that point, there was no formal relationship between scientists and parliamentarians, and so it was sort of deemed a good idea to try and bring the two together with the support then of Churchill. And I think over the intervening, whatever that is now, 84 years, something like that, things have changed. Science is embedded across Parliament now. There is a chief scientific advisor, who we will hear from later. Each department has a departmental chief scientific advisor, but I think as a committee we still play an important role in providing information for parliamentarians more widely, because in today's rapidly advancing world, the interplay between science and policy is increasingly crucial. As scientific advancement transforms our society, parliamentarians must comprehend and respond effectively to these changes. And I think Parliamentary Links Day, this annual 35 years event, serves a vital platform to foster that collaboration, that understanding between parliamentarians and the science community. It bridges the gap between science and policy. It facilitates and informs decision-making and empowers we as parliamentarians to navigate the challenges and opportunities presented by rapid scientific progress. The interaction between parliamentarians and the science community holds, I think, immense significance in contemporary society. Science and technology, as you well know, being in this room, are central drivers of progress and innovation across various sectors, from healthcare and communications to energy and the environment. Parliamentary decisions profoundly impact these domains, making it essential for lawmakers to be well informed about the latest scientific advancements. So therefore, by engaging with scientists, researchers and experts such as yourselves, parliamentarians can gain access to expert knowledge and evidence-based insights, and of course, emerging trends. And evidence is a word that perhaps we don't use enough in Parliament. We've got Evidence Week coming up soon. I think evidence is vital. Whether we take it or not is another question, but what we should do is not dismiss evidence as a good basis for this. And this interaction enables us to make that evidence, to make informed decisions, which ultimately leads to effective and hopefully forward-thinking policies. The pace of scientific progress, I think, has accelerated at an unprecedented rate, with breakthroughs and discoveries occurring with remarkable frequency, from artificial intelligence and genetic engineering to renewable energy and space exploration. Rapid scientific changes have profound implications for society. Most recently, we have seen, to an extent, the moral panic surrounding the explosion of AI, particularly through access to ChatGPT. And parliamentarians, as policymakers, need to comprehend and respond to these developments in a timely manner. And I think Parliamentary Links Day provides that unique opportunity for parliamentarians to engage directly with scientists and gain that deeper understanding of the scientific landscape. Because together we can explore emerging technologies, grasp the potential impacts and ethical considerations, and gauge the public perception and concerns surrounding these developments. The interaction between parliamentarians and the science community enriches the policy-making process. Science provides, as I said, evidence-based foundations for decision-making, enabling us to develop robust policies that address societal needs, challenges, and aspirations. By collaborating, we can do things better. We can anticipate what the future might hold and develop policies to harness scientific advancement for the benefit of society. Additionally, such interactions foster that interdisciplinary thinking that you all do so well and encourage us to consider scientific perspectives alongside social, economic, and ethical factors when formulating policy. So, in conclusion, Parliamentary Links Day plays a vital role, I think, in fostering better understanding between us and you. And as long as I remain as chair of the Parliamentary and Scientific Committee, I hope that this event, I would be my hope to be able to play a role in this, to be able to continue to offer my support and make sure that this interaction continues. I hope you have a great day. I hope I know we are going to hear some very interesting speeches. We've got a fascinating panel to come. The theme for today is about the role of science and technology in economic development, something which I'm sure we are all very interested in, regardless of our political persuasion. And that is demonstrated today by the support that both of the main parties have given to today. And we're going to kick off with my friend and colleague, the Minister for Science, Research and Innovation. Is that right, George? Perfect. George Freeman. And then we're going to hear from my other friend, the Shadow Minister All of us have been working on this important area for many years because I think we all passionately believe the same thing, that our future is best served by working together with you, which is why we are all happy to support you where we can. Ladies and gentlemen, George Freeman.
Well, Stephen, thank you. And thank you all for coming on into a hot room. I don't know if there's anything we can do about the air conditioning. If anyone's got the button, it'd be great to turn it up to max. Look, this is an annual fixture and it's a brilliant event. And thank you to Stephen and all the Royal Society of Biology for pulling this together. It's a really important day. I really want to say something about biology, actually, and about the bioeconomy and bioscience and the age of biology, rather than list through for you and rattle off all the things that I'm trying to do and that we're trying to do. But let me just start by saying it's also a real pleasure, Stephen, given your advocacy, to be with you again. And you and I have been two constants in the fixed landscape of what I call a fairly tumultuous last 13 years in government, and to thank you for all that you've done for this. And also to say what a pleasure it is to be with Chi again. Now, Chi and I have an interesting relationship. Most times I speak, she's there. She cross-examines me forensically once every 6 weeks in the House. And we get on very well. We disagree, of course, about some things, as you'd expect, but not as much as you might think. And it's really important, I think, that Chi and I have a good relationship and that she's here, because at the end, you get towards the end of a parliament, in long-term policy sectors like this, it's really important that stakeholders, researchers, scientists, companies, investors can see that there are things that aren't disagreed on. And the importance of life science, the importance of bioscience, the importance of science, research, technology, innovation to our economy is one of those things, which is why I've done it, to the frustration of some of my colleagues at times, for 13 years in a very non-partisan spirit. And it's why I always pay tribute to Chi and to Daniel Zeitner whenever I'm with him, because I think partisan politics sends a really bad signal. There's a place for it, but this isn't it. And actually sending a signal, listening, talking together and developing a framework. And if Chi comes to take on my job, I want her to say, look, he wasn't trying to do the wrong thing. I just want to do it better. So I just want to say that I think it's really important that we work in that spirit. And that's why this last weekend, I was delighted to convene our 6th Big Tent Ideas Festival. And Stephen Kinnock, there were people from Labour, Lib Dems, Green, and lots of non-aligned groups trying to raise the big issues in our society that need to be discussed. Look, second message, it's great to be back. I've had a volatile career, and the point I'd make is when I started as the first Minister for Life Science back in 2011-12 with David Cameron, by the way, then people were saying, why are you always banging on about life science? There are other things, you know. Why are you always banging on about science research and tech and innovation? There are other things, you know. Well, they're not saying that now. And my message has been consistently that if you want to escape the boom and bust economics and therefore politics of an overly London concentrated service trickle down city economy, then we have to invest more and do more to make this country what it is in its DNA, a laboratory for the innovations of tomorrow that'll tackle our own domestic challenges, and boy, they're huge, and be a test bed for those global challenges, which are even bigger and more urgent. And in fact, I argued to David Cameron, please don't make me Minister for Life Science. Can you make me Minister for the science of life, for the bioeconomy, for the decade, the century of bioscience? And I think now we're coming to that point as well. Life science has come to mean biopharmaceuticals. It's a huge sector and it's key. But I want to talk a bit this morning about the broader bioeconomy and bioscience, and in particular, 2 key bits of it. And I just to set the scene, I hope you've seen what I've done in the 18 months since I've been back. I've tried to set out a very powerful vision of this country shifting from being a service economy with deep science in silos, often quite bureaucratic, slow, top-down political, traditional silos in which the junior researchers get to do the junior doctor thing of working in a lab and filling in grant applications. And we're taking a lot of our talent for granted in a system that's not fit for the pace, agility of 21st century S&T. So there's a bunch of reforms there to the UKRI ecosystem, the grant reform, Tickell reform, the nurse review, to try and make that ecosystem more like a Formula One engine, which isn't, I think, how it feels to anyone at the moment working at it. And the science superpower piece is about us being more energetic, muscular globally, in insisting we don't just want to win the prize for studying the problem. We want to go and try and solve some of these problems, from agri-tech in Africa to help avoid 100 million people walking out, to sorting out clean oceans, to understanding how we really transition to net zero in the cities of tomorrow, to cleaning up space, to biosecurity. We can't do it all, but we can lean in and be a much bigger supporter in some of the key areas. And that's why in the G8 and the G7, G20, I've been making the case that science is our great superpower. And the UK's mission is to be the biggest, strongest backer of that notion and to deploy our science as our soft power force in the world. And I'm really delighted that is now embedded, paragraph 1 of the integrated review. The story we tell ourselves about this country isn't we're a major defense superpower on the front line of the Cold War. The story, read the integrated view, is we're a science, research, technology and innovation powerhouse helping the world as it tackles these phenomenal challenges like doubling world food production on the same land area in 27 years with half as much water and energy. I'm optimistic because I know what powerful our plant and agri-science are, but we haven't connected it properly out to the world. And my argument is you can't do that unless you're an innovation nation, unless you're actually in your own economy, using your procurement freedoms and regulatory freedoms, whether you voted for them, I didn't or not. We've got them, they're levers. We're no longer in state aid. We're no longer stuck in slow regulatory systems. We can set the regulatory pathways for new novel foods, for bioengineered crops, for biofuels, for Eng-Bio, for satellite sustainability. And I'm pushing hard for us to create some designated test beds in this country. So we don't just talk about regulatory enlightenment. We create the designated geographies where we measure, world's innovators will come and we set the standards, as well as deploying our finance and building clusters all around the country. And I just, through that work, if you look, I'm on cluster tour 17, going around the country, highlighting that, yes, the Golden Triangle is golden, but folks, come and have a look at the Norwich Research Park, come and have a look at Warwick Robotics, come and have a look at Glasgow Satellite City, Manchester Materials, Edinburgh Superfast Computing, Edinburgh Animal Health. We're mapping them digitally, and this autumn at the Global Investment Summit, we'll be setting out an interactive digital map showing the breadth of our science, research, tech and innovation. And bioscience underpins a huge number of those. And for me, the most exciting area is where food, medicine and energy come together. And before coming to Parliament, I helped to set up the Norwich Research Park Investment Fund. And where those three come together, some really exciting things happen. Like what? Well, like some of you will have heard me say this, the Formula One Lotus car that I sat in, powered by low carbon biofuel made by gene edited bugs breaking down agricultural waste. Now that is bioeconomy 2.0, or the blight resistant potato developed here in the Norwich Research Park, sadly banned by the EU, commercial growth. It would mean we can grow potatoes without 14 applications of toxic fungicide pulled by very high carbon machinery. So biology is on the cusp of agri and energy, and in medicine, the Gut Biome Institute, which I'm delighted to put more money into, the science they're doing is beginning to tell us that actually a lot of our long-term disease disposition is embedded in prenatal diet, is embedded in how we feed our bodies, which actually drives some gene changes. That diet, nutrition, gut biome are absolutely fundamental, and we can learn from the gut biomes of other species. So nutrition, food, medicine, energy, I think we're on the cusp of genuinely a century of biology and bioscience. I think the chemistry and physics have had it in the last century. I genuinely believe this is ours, and it won't just be one B silo, it'll be biology powered by those other underpinning technologies. And I want to highlight just quickly too, biosecurity and bioengineering. So you may have been surprised that in the 5 hot geopolitical strategic technologies we've set out that are on the front line of the global race, technologies that if we don't make a move, we'll end up either with somebody else owning it and using it against us, or our best people and talent being sucked out by other nations. So they're 5 geopolitically hot ones, and bioengineering is in there. Last week I was in Boston and in Canada and going around the world to try and find out where we have a real opportunity. And we'll shortly be setting out a big plan for the next 10 years to bring this sector together, and it'll cover a whole raft of investments in skills and infrastructure. But here's the real point. When people say, what is engineering biology? And I say, well, if you accept that we have to move to a post-fossil fuel world, look around you at all the plastics, all the packaging, look at all the things that are based on the derivatives of oil refining, and now replace them with something that isn't. Engineering biology has the capacity to be, and I don't think we think enough like this, it's one of the reasons I want to mention it, think of it as the transformational production paradigm shift of the 21st century. And don't take it from me, take it from companies like Unilever and Procter & Gamble and big companies who are looking down their supply chains at how they can replace with a whole new raft of materials, crops, fuels. So it's a hugely exciting area, which we're good at, and don't intend us to drop the ball. And the other is biosecurity. When I left government, courtesy of Dominic Cummings for having the temerity to suggest that a no-deal Brexit would be bad for British business, didn't think that was heresy in the Conservative Party, but for a brief while it was. I went off and set up a Global Health Economic Resilience Commission to ask the questions, what is this pandemic revealing about health economic resilience? How do you score the resilience of a company, city, country, sector? And we're now looking at biosecurity, and I'm arguing we don't just need to have a compliance kind of, have we got more PPE, are we ready this time? We should be setting up an international network of sensors 24/7 in the big people moving ports, in the places where phytosanitary security, animal, plant, and human health is absolutely key. It'd be sort of Canada, Ottawa, Montreal, us, Rotterdam, maybe Singapore, Japan, Australia, countries that cannot afford to be caught napping by a plant, an animal, or a human pathogen. 24/7 sequencing, fed back data share to an automatic gene sequencing unit. We could look 24/7 and go, oh, that's a bit of residual COVID. That's, oh, look, bit of smallpox, glad that's under control. Unless we're literally taking this seriously 24/7, I think the next pandemic, which may well come sooner than we think, will catch us napping. So I think on the front line of our security, the biosector has got a key role, and then deeper in terms of building the industries of tomorrow. So thank you for all you're doing. I hope you can tell that you've got ministers who get it and back you, and I look forward to working with you in the coming months on the Eng Bio strategy, and more importantly in the coming years on making sure the world recognises that biology is now on the front line of this country's future. Thank you.
Thank you very much, Minister. And I think I'd follow on from that to say that we are with you, on the journey across the whole of the science spectrum, not just bioscience. And one of the great strengths of all the organisations in this room is that we have representations across the spectrum, from technicians to all the sectors, to private sector, to the public sector. And do use us to inform that debate. We'd love to come and talk to you and find out a bit more about that. So we are there to help if that's what you'd like. Thank you for that. And I now have great pleasure to introduce Onwurah. Chi has also been a huge supporter of this event and others over recent years, and of course, a member for Newcastle upon Tyne Central. And we'd be delighted to hear what you've got to say, Chi. Thank you.
Thank you very much, and it's so great to be here, and thanks to the Royal Society of Biology for bringing together so many learned societies, but more importantly, so many scientists, engineers, technicians. It's always a real inspiration to me to look out on a room full of people of scientific backgrounds who care about politics enough to come into Parliament on a hot day like today. And it's really great to see you. Parliament really needs you. And I also want to say a big thanks to Stephen for all the work that his kind words, but also all the work he's doing and he has been doing on science, on the Science Technology Select Committee and the Parliamentary Office of Science and Technology, and the really important promotion that Stephen does as part of that for science. And of course, a big thanks to George for setting out, well, for his kind words and for setting out his vision of science and biotechnology. I think it does demonstrate, as George said, that science is really a cross-party good. We all believe in the value of science and evidence. Last night's debate may have demonstrated that the relationship between Parliament and facts or the truth is not always, what it should have been. But I think the vote also demonstrated that the vast majority of parliamentarians believe in the importance of rooting our debates and our legislation in the evidence, and facts, and ideology comes after that. And as some of you may know, I'm a chartered engineer. I spent 2 decades in the sector before coming into Parliament. And I always say, that I went into engineering for exactly the same reasons that I went into politics, even if it was quarter century afterwards. And that is to make the world work better for everyone. And that is what science and engineering do. I was recently speaking at SynBio Beta in San Francisco, the world's largest synthetic biological engineering conference. And I have to say that what I saw then, and George touched on it, what I saw there absolutely sort of blew my mind in terms of the potential for transformative change in so many sectors. And biotechnology is really at a kind of a point that I think that telecommunications, which was my sector, was at 40 years ago, say, when it's on the cusp of really transforming what we're doing. And that is so important that the UK can and is in some respects at the forefront of that. I mean, we do have such a proud scientific tradition, from Isaac Newton to Stephen Hawking, from Ada Lovelace to Rosalind Franklin and Jocelyn Bell Burnell to Newcastle-born, I always have to get that in, Peter Higgs, who discovered the Higgs boson. We have scientific giants which bestride the world, and our science and research continues to be absolutely world leading. Now, I'm a strong believer in science for science sake. I think it's part of what makes us human, to push forward the boundaries of knowledge. But as well as pushing forward the boundaries of humanity's collective understanding, science represents a priceless platform for the UK's future growth and prosperity. And that's the key theme for today's Parliamentary Links Day. Science is absolutely key to our economy. And of course, throughout the pandemic, it was paramount to our public health. So investing in research and development and science is a no-brainer for our economy. And the Campaign for Science and Engineering, in the room, have found that for every £1 invested by the government on research and development, we get 20 to 30 pence back each and every year in perpetuity. And so that's one of the reasons why I'm so delighted to be part of a Labour front bench under Keir Starmer's leadership, which absolutely gets the critical importance of science and research and development to our economic future, and has set out 5 missions for government. Science is absolutely key, central to delivery of these missions. Our missions are securing the highest sustained growth in the G7, building an NHS fit for the future, making Britain's streets safe, becoming a clean energy superpower, and breaking down the barriers to opportunity at every stage. I'm just going to talk briefly about how important that science is to deliver those missions, but I do want to emphasize why we are taking a mission-based approach and how important that is to it. So I think George would admit, I think, that we've seen some, in fact, you said that since we came into Parliament 13 years ago, and particularly over the last 2 to 3 years, we've seen some, let's say, changes, rapid changes at times in government and government ministers and the machinery of government and the objectives of government and the science. We did not have a science minister for a few months, and then we weren't sure who was the science minister for a few months. So I think it's really important that business and science and technology in the sector has the kind of, you can never have total certainty, as we know, but the kind of confidence that comes from knowing been clear about where government is going. And that's what the missions are trying to achieve. So that, you know, saying what our national objectives are. And the importance of the key mission of having the highest level of growth in the G7. You know, the lack of growth in our economy over the last decade is one of the reasons why finding the funding for our great public services is such a challenge. So to deliver that growth, we are clear that sustainable growth can only come from a science and technology-based economy, that the only way that my constituents in Newcastle are going to have access to the high quality, high productivity and high wage jobs is if we have an engine for research and development and economic growth in the Northeast, and that applies to the whole country. So we also need to have innovation in science. As George said, talked about clusters. We need to have innovation in science recognized as something that is for everyone and for all across our nation. So that's why Labour and Power would champion universities and clusters of universities as engines of regional growth, providing them with the resources to collaborate and innovate together with local businesses to drive regional innovation. And that would also spread the success, or help spread the success of the Golden Triangle far beyond the geographical boundaries of that triangle. And it's also science that can help us address the great existential threat of our time, climate change. And that's why one of the missions is clean energy. But as an engineer, I am really excited by the role that engineering and science can play in addressing climate change, whilst also delivering on the need for net zero and delivering on the challenge of good, sustainable green jobs. And that's also net zero is something that inspires young people to see science and engineering as being for the good of the planet and for the good of our future. And that's why we're committed to a 3% target for GDP invested in R&D from public and private sources. And Labour's Green Prosperity Plan provides the investment and the roadmap to becoming a clean energy superpower. So all of Keir launched our NHS Fit for the Future mission and talked at quite some length about the importance of science and technology driving innovation through the NHS, an NHS which has the workforce, which means it can get on with its day job, whilst also driving innovation, which means that we can have an NHS which delivers on its promise of health for everyone, whilst taking advantage of the new innovations in clinical treatments. And we all know that we need to fix the challenges we have right now around clinical trials in this country. So I'll stop there, but all, you know, Labour's missions in government are all driven by and based on science and technology, and that is a part of our economic prosperity plan for economic prosperity, as well for the well-being of all our constituents. And we have great advantages in the UK. We have our coast, our shallow waters, our universities, our scientific heritage, the City of London as a leader in green finance, and even our weather, though at times it doesn't meet its reputation. So science and technology will underpin Labour's mission-led government, and our tech sector and our commitment to meeting our climate change objective. It not only makes our missions possible, but it means that it is fundamental to achieving them. So working in partnership with researchers, with business, with civil society and trade unions, we will grab hold of the potential for national prosperity that science and technology opens up. And I want to say how much we look forward to working with you to achieve and realize the potential of science and technology for everyone, and to make and I'll share George's phrase. So I think we debate who coined it first. An innovation nation where innovation isn't something, or science isn't something that happens in an ivory tower somewhere else. Science is something that matters and is part of the lives of all of everyone in society, and everyone in society feels they can take a part play a part in it, because science and the culture of science reflects our great country and all the people who play a part in it. Thank you very much.
Thank you very much, Chi. And I think the same offer extends very much as it does to the government, to the opposition. You know, we'd be delighted as a community to engage with you as you develop your manifesto, and indeed with any of the political parties. So obviously get in touch with us. I think that today I've stressed already that we are operating on behalf of the whole science, technology and engineering community. A lot of what we do, of course, is about integrated science. That means we work together, and biology, chemistry, physics, mathematics in particular, I think are very focused on having common messages, a common understanding which we present to policymakers. We're going to hear a little bit of a broader discussion now, and you'll have an opportunity to participate. But against that backdrop, I think it's particularly delighted to be able to welcome Jo Reynolds from the Royal Society of Chemistry to lead the panel discussion. And Jo is Director of Science and Communities at RSC, and I'll leave her to introduce the panel. Thank you very much.
Good morning, everyone, and I'd like to invite our panel to come and take a seat at the table.
Hello, everybody. I'm David Leslie. I'm a professor in statistical learning in the Department of Mathematics and Statistics at Lancaster University. My research is on a less plate area of artificial intelligence than you may otherwise have heard about, where we care about interfacing decision-making and inference and data gathering all in one go. It's not well studied in the foundation model sort of world you might have heard about, but we still think it's quite important. I'm here representing the best ranked mathematical sciences department in the country in terms of research impact, which I presume is why I was asked. As a department, we interface with a very wide variety of companies and government departments, and we reward research engagement in our promotional processes, which is why I think we do well at it. Personally, I collaborate with the likes of Amazon, Google, Microsoft, BAE Systems, Shell, at various tech startups. At the moment, I'm working on some retail pricing research. So the correct price to sell a product is clearly kind of important. It depends not only on background economic factors, but also what your competitors are doing. So it's important to always research and experiment with your pricing. But experimenting is expensive because you sell things at the wrong price, you lose money. And so my research can help work out when and how much to experiment to make sure we choose the correct pricing. In terms of how to maximize the impact of mathematical sciences research in the economy, there are several impediments. One is I think that our community is very careful. We're not particularly good at hyping and marketing, and so we get marginalized and people don't know what we can do. As an AI researcher, you might expect me to say that a lack of computation in the country is a big problem. And all the times, the companies I've worked with, computation has not been a bottleneck. I think the view that computation is critical to AI is one particular view from a niche aspect of artificial intelligence. Yes, it's a currently successful area, but I think we're in danger of putting all of our eggs into that one overhyped basket, and some diversity of funding will help mitigate the opportunity costs from not studying other aspects. What is more of an impediment is data availability. Only the global tech leaders have the kind of data that is necessary to be able to apply modern AI methods out of the box. What we instead have is every company has a small amount of data that is relevant to their particular problem, and they need skills to be able to take that data and their internal expertise and turn it to solutions to the problems they have, instead of telling them whether their customers are cats and dogs. That brings us on to the other key impediment, which is a lack of skills. We simply do not have the skills pipeline in this country to make sure there are sufficiently many people out there who can understand what mathematics can do for the economy. And I think that is a key impediment to be able to do more in this country for the mathematical science and the economy. Thank you.
Thank you very much, David. Now, I'd like to invite Diane to give her comments.
Well, thank you very much. Thank you for the invitation to take part in what is my first Parliamentary Links Day. It's a great pleasure to be here. I'm the co-director of an interdisciplinary public policy institute set up in Cambridge 5 years ago, so we're relatively young. I'm an economist researching the impact of digital technologies, which I've been looking at for the past 26 years, I think, and also natural capital, so two that touch on two completely different areas of science, and the implications of that for productivity and economic growth. So the first thing I want to say is that scientific discovery is the economy. It's not just that it's an important driver, it's that the increase in GDP that we use to measure economic progress is the embedding of scientific and technical discoveries in new goods and services that people value. And that's what it's all about. And without that kind of discovery that's taken place over centuries, but particularly in the past 300 years since Adam Smith was born, we wouldn't have longer, healthier lives, we wouldn't have more leisure, and we wouldn't have all the many things that contribute to the quality of life. The medical devices, the vaccines, the safer vehicles, the renewable energy technologies, and yes, ChatGPT. But of course, none of this is a golden ticket to nirvana. It's not that easy, because the application of any scientific discovery involves economic incentives, it involves politics, it involves accidents of history. And discoveries have long-term consequences that are unpredictable. So the internal combustion engine would be a fantastic example of that. First it was fantastic, and then it was not so good. Or the science that has gone into delivering us a food industry where we in this country are eating a very highly processed diet that's harming human health. Or who knows with AI. So these unintended consequences over the long term are probably inevitable, but it means that we're always thinking about the course corrections as well, and what's the context for the use of science. Now, at the moment, we have two major technological transformations underway in our societies. Economists call them general purpose technologies because they apply not just in their own sector of application, but across the whole of the economy. And that, of course, is digital and communications and information technologies and the energy transformation. And when we get these two kinds of transformations together, we call them things like the Industrial Revolution. And that has good aspects and it has bad aspects. The benefits of such big changes need to be really widely shared for them to stick and to deliver that economic growth. And that means engagement, listening to people's concerns, and it's a crucial time for politicians and policymakers to engage with science and technology, with how scientific discovery is shaped and implemented. What's the direction of innovation? What are the structures that determine which market needs are satisfied and which are not? What are the governance and regulatory frameworks that enable that wide sharing of benefit and the safe deployment of different technologies? What skills and infrastructure are needed? And how to bring all the different areas of expertise together. I completely agree that computation is not the binding constraint on growth at the moment. I've just done some work looking at the price of computation. It's declining incredibly rapidly, and that decline has not really slowed down very much. But it's nature that's the binding constraint on growth. We have used natural resources for free since at least the Second World War, when it looked like resources were plentiful and physical and human capital were in short supply. Now it's the other way around. We are running up into the constraints of nature. So we need to bring those domains of expertise together. But any applied scientific challenge is also a social challenge. And so bringing together the social science questions as well. Because what I think we're all about is, the tagline I use is the right kind of growth fairly shared. That's not going to happen without science, but I think it's a really timely moment to be having this kind of conversation among all the different groups represented here today and with the policymaking community. Thank you.
Thank you, Diane. Johnathan.
Thanks very much. I've got a slightly croaky voice. If I'm hunched over the microphone, that's why. So I'm from Rothamsted. My background is really, I'm a plant biotechnologist, and I'm for a long time I was sort of a fundamental scientist who just was driven by curiosity and was interested in just doing discovery research. And discovery research is what the UK is brilliant at. You know, we have an amazing record for discovering new and interesting things. It's something that really sets the UK far above it sort of, you know, many sort of similar sized countries. And probably about 10 years ago in my research, I realized something, I discovered something that we were trying to engineer plants to make omega-3 fish oils. So we'd have a sustainable source of fish oils. We actually realized that we could do that. And it seemed to work. And then I suddenly realized actually that what was really difficult was translating that research. How do you move something from a discovery to becoming a product? How do you actually do that? And then you realize that actually that a lot of our efforts are configured around discovery, and they're much less configured around innovation or translation, or probably in old money, it used to be talked about doing applied research, which was sort of viewed as very much a subsidiary activity. I think it's incredibly important. And I think it's really, you know, so my sort of clarion call, croaking though it is that, you know, we need to really think about translation. And because, you know, we have so many global challenges to face, you know, we're aware of all of those. And at the same time, we know that science, it's going to be science that's going to get us out of the hole. We learned that from the pandemic. It was science that came to the rescue. And I'm hopeful that will be how we address the global challenges we face now. But so how do we convert those discoveries, those, you know, that they could have already been made in our universities into something that is useful? So how do we do that? And, you know, and I think that's, you know, that's the challenge. Ultimately, it takes, you know, it takes time, it takes focus. It needs a shift in mindset that says it's not just about being on this endless hamster wheel of discovery. We need a sort of off ramp that allows us to actually somehow to exploit all that knowledge and use it to deliver benefit, economic benefit, societal benefit, you know, human benefit, environmental benefit. All of those things are possible. You know, so how do we do that? I mean, that's the challenge, but that's part of the dialogue of a day like this, is really about that, to try and help, you know, to catalyze that thinking. So ultimately, you know, it's all going to boil down to, invariably it boils down to money. You know, we need to invest, but we need to invest in the right places, and we need enabling regulation. You know, and in the field I'm in of gene editing and GM, it's great to see that the regulation has been enabled to make that easier. And we just need a sort of cultural shift that views translation, application as actually being the end point for what we're doing with research. Because most of the time it's sort of seen as a sort of addendum, but really it should be the direction of travel. It should be the thing, it's the thing that the science should say, I want to demonstrate this has utility. And I think that's everything I was going to say. Thank you.
Thank you, Johnathan. And Sarah.
Thank you very much, Joe, and good morning, everyone. It's a real pleasure to be here. My name's Sarah Main, and I'm the Executive Director of the Campaign for Science and Engineering. I was feeling a little nostalgic on the tube on the way in today, because this month, June of 2023, marks 10 years for me as the Director of CASE. I started in June 2013, and Parliamentary Links Day in June of 2013 was the first big event that I attended in the audience. And Steve and Ben, who we might hear from later, kindly invited me on the panel the following year. So I've always enjoyed being here. And back then in 2013, you know, science and economic development was very much on the agenda. That was a period post-financial crash when Cameron was Prime Minister and we were in a period of austerity. It was a time when a flat cash outcome for science was a big win and was the thing that we were all pressing for. We at CASE worked hard to bring about the evidence that science was relevant to economic development, and we did that in collaboration with many of the organisations in this room, as members of CASE, and also as organisations that specifically supported our work in that area. One of the pieces of research that we did that had probably the biggest impact was an economic study by Johnathan Haskell and Alan Hughes called the Economic Significance of the UK Science Base, that was supported by about 6 learned and professional societies. And it examined total factor productivity growth and made a strong economic argument for the value of public investment in science and R&D to the economy. And it gave that piece of evidence that the Shadow Minister Onwurah cited earlier, that for every pound of public money invested, there was a return to the economy of 20 pence in perpetuity. That piece of work, I would say, was significant. It had a significant effect on Treasury thinking and has become very highly cited. It's become a little bit part of the financial orthodoxy. And we have seen a lot of progress over that time, over those 10 years, in the prominence and profile of science and R&D in government and in their economic strategies to further the prosperity of the UK. So we now see science and R&D being talked about at a high level in government by chancellors and prime ministers, and in significant economic strategies like the industrial strategy and the levelling up strategy of a few years ago. So it has been very successful. But if I think about what its limitations might be, you know, what was missing from that piece of work, I would say, you know, if we could have our time again, we might have developed alongside it a strong, coherent national narrative for R&D, a national conversation about being a science positive, innovation positive UK. Of course, we do need strong economic evidence and argument, and that has to be right for the time, and it has to adapt with the time. I think since that piece of work was done, we've seen the rise of the intangible economy, for example, and that, you know, the quantification, the understanding, assessment of the value of science and research to intangible benefits in the economy is a really live discussion at the moment. For example, in the consideration of whether or not we continue to participate in European research programs in the form of Horizon Europe. But we know, we kind of sense, I think all of us in the room, we know and appreciate that a conversation just about numbers in and numbers out is not enough. It's not enough to win hearts and minds in the public. It's not enough really to win long-term public support. We need the UK's incredible scientific capability to deliver for people, for everybody. And we need individual people to feel the benefit of being part of a country with incredible scientific capability. Now, huge progress has been made in this area, and I think all of the organisations in this room deserve the credit for that. There's been a vast array of work done on inclusivity and reaching out and engagement with much broader audiences on the value of science to the UK and the economy. But I think you would probably agree with me that there is no doubt that there is further that we can go. You know, are we at a position now where every person feels that the UK's scientific capability benefits them individually or benefits their loved ones, their nearest and dearest in their families? Are we in a position right now, today, where every student in a school and their parents and teachers feels that a job in the science economy might be the right thing for them? Does every person working in the science economy in some way feel sufficiently supported to continue to think that a role in the science economy is the right thing for their future? And I think all of us can answer that in different ways, but I think we probably all agree that there's more that we can do. I wanted to focus really on two things I want to talk to you about, the things that CASE are doing in this area. Firstly, thinking about skills. We've just recently published a report called The Skills Opportunity, which really calls on the government and devolved administrations to coordinate and support an integrated skills system to deliver a more innovative and research-intensive UK. To me, the point of this work is to show that skills right across the economy, in technical education, in employer upskilling and reskilling, in immigration and in higher and further education, they're all part of becoming a more research-intensive, innovative UK. We have the investment commitments from government, you know, we have substantial strategies which the Minister has talked about to progress the UK as a scientific nation, but you need a people strategy to match. And that people strategy needs to embrace the whole of the economy and all, you know, different parts and roles that people can play in it, not just the higher and higher levels of PhD and so on education. A second piece of work we've done looks at public opinion. The Discovery Decade programme is really trying to understand people's own responses to R&D, to thinking about what that means for them in their lives. We're trying to start with a baseline understanding of the temperature of public opinion at the moment. We know that whilst there is broad support that actually a majority of people in all UK regions feel that it's somewhat important that their region carries out a lot of R&D. And we know positive things from this, that there is support for appetite to hear more about R&D in local economies. 2/3 of people would support a new research lab being built in their local area for reasons of benefiting the local economy, well-paid jobs, educational opportunities. And that option of a research laboratory comes second only to building a new school out of a set of options of 6, which include retail and other options. We are working with this data to try and bring that to life in real world ideas and messages. And we're now starting the first of a series of workshops in Belfast, working with that local area and region to bring this evidence to life and show what it could mean for a local campaign. So I want to leave you with the thought that science and economic development will definitely be part of the campaigns of various political parties for the next general election in a year or so's time. Let's make it a coherent national narrative that embeds science and innovation as part of the UK's future.
Thank you to all of our panel. So we've touched on quite a few topics there, ranging from the investment in science to unintended consequence, to the importance of the skills pipeline, the challenge of translation, engagement with the public and helping them understand and both a national picture and a local picture in terms of science and economic development. Now's the opportunity for you to ask your questions. If I can ask you to just pause and wait for the microphone to come and then stand up, state your name and your affiliation and then ask your question. So I think the gentleman here was probably the very fastest to put your hand up.
Thank you. My name's Sandy Starr. I work for a charity called the Progress Educational Trust. And together with some of Diane's colleagues in Cambridge, we work on a project called Governance of Stem Cell-Based Embryo Models. These are the things you may have seen in the news in the last few days, entities or materials created from stem cells rather than from fertilization that in some respects resemble human embryos. Now, the UK researchers working in this area are very keen to demonstrate responsibility, transparency, and deep ethical reflection as they explore the frontiers of this very important area of research, which could unlock secrets of disease, development, and reproduction. And I'm interested in the thoughts of any of the speakers as to how best to go about that. I mean, these researchers have, of their own initiative, become involved in this project to develop the UK's first dedicated governance framework for this particular area of stem cell-based embryo models. So clearly that's one path. But I'd be very grateful for any thoughts related to that, given this quite complex and sometimes ethically fraught area in which they're working.
Thank you very much. Would any of our panel like to take that question?
Shall I have a go as the sort of most biological? That sounds worse than it's meant to. Sorry. I mean, I think it's great that, as you say, that you know, the researchers are themselves thinking about the ethical framework that they should be operating in, because I don't think 10 or 15, 20 years ago, that mindset was really very apparent. So I think it's a reflection on how far we've traveled, that, you know, that the concept of responsible research and innovation is now really embedded in the research culture in the UK, and I think that can only be a good thing. But you know, I think it's a continually moving forward front. I think you can't just say, well, you know, I've set up an ethics committee and that's it, and my job is done. You know, I think because we're always encountering new issues, whether it's, you know, what can AI do for us, or, you know, how is gene editing going to impact on our lives, or all of these things. I think there is always going to be new questions, and I think people need to be, people just need to think about it some more. And I feel part of the role of scientists is also having communication, dialoguing with the public to inform them about what it is that they're doing, but in a way that is completely accessible to the public. So not assuming that the public should have a PhD level understanding of what it is we do. It's like, it's my job to find the right words to explain to a layperson what it is that I'm trying to do. And more importantly, why I'm trying to do it. Because actually quite often the why is more important than the how. The nuts and bolts of what you're doing, it's probably may not be that relevant, but the why you're doing it, if you're saying, I'm doing this because I want to get filthy rich, I think that could, maybe alarm bells start ringing. Whereas if you say, actually, I'm trying to prevent this horrible disease, or prevent economic fiasco in this part of the world, then maybe that's more accessible.
I had one sentence, which is, I think the communication part is very important, but it's two-way. I came across this wonderful phrase, communicating with your ears. And the experience of the past with the Warnock Commission on Embryology, for example, was that sort of very time-consuming and intense public engagement was really important.
I'd just add that I don't think I have any specific advice in your case, but I do think the general point that you're making is one where the UK can have a distinctive advantage. So now that we are in the situation that we are outside of Europe, and the government is looking to find the benefits of that, I think that the ongoing work by it's initiated under Patrick Balance and is continuing now on how we can best use regulation, governance, ethical considerations to support dynamic and innovative science, but in a way that really does properly engage the public, I think is an area where the UK can have an advantage, because we do have well-respected and robust legal systems, regulatory and governance systems, and I think a good framework for ethical dialogue. And that, I think, can be an advantage for the UK that we can offer as a place for innovative research progress.
Hi, my name is Katie, and I'm a PhD student at the UK Centre for Ecology and Hydrology. Thank you very much for your very interesting introductions and talks. Thought it was really great, and it's a pleasure to be here. I just want to say, as a young person in the ecological sciences, I'd say that the most pressing issues that we can see happening are climate change and the biological, ecological disasters. Sorry to make it sound very, I don't know, dramatic, but that's what it is. And we can see, I can see loads of research being done and lots of outputs happening and potential solutions to these problems being produced by research institutions and universities across the country. And as something that Johnathan sort of mentioned was that there is a wealth of research out there. How do we get that into politics and get things sort of moving and happening and solutions happening on the ground? And that's kind of something I just wanted to ask about, because we have several routes through which evidence can make it through to government and parliamentarians, for example, through select committees, and we have Parliamentary Office Science and Technology, and briefing reports are being produced by scientists, and there are very many different routes through which this seems to be many routes through which science can get through to government. And yet it does feel like, from our perspective, that not much is being done. So what do we as scientists need to do? This is to everybody, to try and strengthen those links with politicians, to try and actually get solutions happening to the climate and ecological disasters that we're facing.
Thank you. Can I start with David?
Yeah, so thank you for bringing that up. I have actually just finished a 5-year project on data science of the natural environment, actually with CEH, but a different bit to you. My conclusion at the end of that is that the problems here are not scientific. We kind of know what's going on with pretty good fidelity. You don't need any more stats input to understand what's going on there. It's all policy, right? We're all here today. Our colleagues who are not here today are at home writing papers which will further their career. The incentives for the scientists here are not correct. The incentives are to get more papers published, win more grant money, and push up the career structure. So I think we need to support engagement better in the university structure to get people down talking to politicians. I experience that as politicians are very happy to talk to you. when we try, but we don't try enough. I think this is a part of failure in the academic community of not spending enough energy on engagement with the political process.
So I'm going to say it's not spending enough time talking to the social scientists.
I'll buy that too.
Because it's arguments about economic incentives, it's about what are the growth and investment opportunities. So it's the way that the discovery is shaped as part of what's going to make people in society better off. And so that's why I'm so absolutely passionate about interdisciplinary research, and why I'm here today to persuade the scientists in the room that it's worth talking to the economists and the political scientists, because if you want to do what Johnathan says and translate the discovery and make it worthwhile, then we've all got to be engaged in.
So I mean, obviously you end up sort of, everybody agrees with everybody these things, but and I know from my own experience that it's really important to do exactly as you say, and understand, you know, get out of your silo, your little scientific discipline, and sort of move to interact with sort of wider and wider and wider circles. I mean, I think what worries me in the space of agriculture, and which is the area that I'm in as well, is that, you know, and there's a lot of really excellent economic analysis. It shows that the average amount of time to go from an idea where somebody says, well, I wonder if we change this, to it becoming an actual thing, a practice, a product, is just under 30 years. 30 years, right? So like the guts of a scientific career, you know, those are not the horizons that politicians think things are happening. They think that the impact, if they change a lever here, there will be a, you know, a policy lever here, there'll be an economic impact here in 2, 3, 5 years time. I think that's unrealistic. So therefore it's up to us to try and educate and inform that politicians say, like, actually, you know, I think maybe that's not right. Maybe somebody's telling you something you want to hear here, but it's not going to be like that. Because you're right. I mean, my slide deck I've lots of slides from Greta Thunberg, and I love her, you know, appropriate enough for this room, our house is on fire type thing. You know, time is really, really pressing. You know, we need to do something now, and we can't just sit back and assume it'll get sorted out.
I'll do you the favour of disagreeing a bit, just for interest. So I think we must be very, very careful to avoid the kind of them and us language. So I don't think we're a community of scientists and then there's a community of politicians outside the door here. We are all part of a community in the UK who has various parts to play in progressing issues of national concern as citizens that vote at the election, and as you know, your role is as an active scientist, and your institution has a role as well. Now, I think we all appreciate that there are actually, this is a very important question, but there are a multitude of routes by which evidence informs political and policy change. In the area that you've pointed to is probably one of the most prominent, in which public opinion plays a huge part, and so the role of us as messengers, as people that are expert in that domain, in just having those conversations in the public domain to help to seed public dialogue. And that, I mean, there's no doubt that will play into the next general election, the narrative of the party that wishes to be elected. But then, of course, there's different routes of legislation, of policy, of regulation, the different roles of a public sector body, an arm's length body like your own versus an academic institution and so on. So it's quite a complex network of influence, but we can all play parts in different routes of those. And I would contest actually that, you know, no progress is being done, because I think it may feel enormously frustrating, and I understand that, but this is a country in which we have legislated for change, you know, with the net zero target. That legislation is very powerful, and so that is a mandate, if you like, for change against which we can deliver. Now, probably even harder than strategy and policy is delivery. And, you know, for my money, the challenge of the current government and the next administration will be delivering on a set of very sensible strategies and legislation that they have in place at the moment. So the Department of Science, Innovation and Technology has its science and technology framework. It's a really robust, well-informed framework, and we need to find ways to support government and parliament to deliver and start enacting on those.
Thank you. Next question. Gentleman at the back.
My name's William Duncan. I'd like to ask the panel, what do they see as the main barriers for successful commercialization, the translation of science into viable businesses? What are the barriers and what could be done to reduce these barriers? Thank you.
Maybe I should start. Well, that's the question. It's the one that people in this country have been struggling to understand for a long time, because it's been understood for a long time that we're great at the research part and not so good at the commercialization part. And I don't think there's a silver bullet answer to that. And it involves everything from what are the attitudes of young people towards entrepreneurship, what are the skills available, what's the finance available, if new companies are set up, do they just then hope to sell out, or are there other opportunities for them to cash in on their investment? So it's a whole list of economic barriers that are very familiar to us. So I don't think we've got the wrong ingredients there, but we've never quite figured out what the recipe is to get them all to combine. And I don't think I've got anything, any secret insight into how to tackle that. But lots of different things to look at, and that lots of different economists are working on.
I'll give you just one, which I think is potential. So quite often we hear that it's at least one issue. I agree with what you've just said, there's a multitude, but just to point to one, is access to capital. And in the UK, we have narrower and more geographically focused capital markets for investment in research and innovation. Now, again, just to follow up on the delivery point I was just making, the government has a sensible strategy on patient capital investment, which I think is, it's a sound idea. It's been talked about for a while, about unlocking pension funds to invest in more risky, innovative businesses. And again, there has been a lot of progress made there, as you know, William, but moving towards results and actually unlocking those pension funds, I think, is probably the single biggest transformative potential for business R&D in the UK. Because it has the power to make a substantial step change rather than an incremental change, which many of the other barriers that can be identified would release.
So my field's slightly different to some others in that we don't need a lot of early phase investment, right? It's ideas, it's computer programs, we can do this quite efficiently. The real blocker in my world is people. And the kind of people who go out and take the ideas into companies and into government departments are essentially PhD students who are at a phase of life when they're happy to experiment and go and work for 6 months somewhere else. And we can't get enough of them. We cannot train sufficiently number UK undergraduates to fill enough PhD places for what we want to do. And we cannot recruit overseas PhD students because we can't fund them appropriately, and there are visa issues. So a lack of skills pipeline coming through from schools is the biggest hindrance in getting mathematical sciences research out into the industry.
Can I just, if you recall, I talked about the timeline for an idea to become a product in agriculture, and it's 30 years. Now, I don't care how patient some capitalists might be, but those horizons are far too long for most investors to be able to completely understand. So I think, that's a problem. I think in general, I think, I would say I've encountered every single one of the things that you've listed, and they're all problems, or they're all challenges to be overcome, would be a better way to describe it. I think ultimately there are so many things that you just have to put your shoulder to the wheel and say, I will try and overcome this. If I'm convinced it's a good thing, then I've got to try and overcome freedom to operate, regulatory burden, yada yada, all of this stuff.
It's like one of those games you get in a Christmas cracker where you've got to get 6 little silver balls into the holes all at the same time.
I really hate it.
You can't focus on just one of them.
Hi, my name is Eduardo Prediletto, and I'm an early career representative of the British Society of Immunology, and I work for Autolus Therapeutics, which is a cancer therapy company here in London. And I've been living here for 10 years, and going to talk about the elephant in the room. It's okay. I remember that back in Italy 10 years ago, before moving, when I was graduating, everyone was so happy and keen to move here because there were so many opportunities and the science here was amazing. We were so driven to come here in terms of projects. And last week I was in Italy and I was talking to a group of graduates, which was my same age, like 10 years ago. And they were not really keen to move here due to the difficulties of Brexit. Again, I know I'm talking about the elephant in the room, but I wanted to ask the panel, what is the opinion in terms of what is going to happen in the next 5 years from the economic and development point of view?
I think it's really interesting to hear your personal experience and talking to your colleagues back in Italy. I absolutely agree with what you said earlier that the people and skills are the driver of research and of economic development, and so our success in the UK in science and research and our success, which I think is actually reasonably considerable in terms of turning that into business opportunity, has been at least in the framework and context of freedom of movement in Europe for the past 50 years. So it's an important question, is how will that progress in the next 5 years? And I think for those of us in the community that are trying to assess and quantify those things, it is quite difficult to quantify at the moment the sort of immediate and near-term impacts of changes to movement of people. Anecdotally, I think, and I think with some hard evidence, we see universities definitely being able to identify gaps in attraction of students from parts of mainland Europe and also movement of researchers back into Europe. And we've seen, other tangible changes in terms of location of businesses into mainland Europe. Much of this is driven by national narrative, and I think it is important for the current government and next government to, well, firstly, in my mind, to associate to European research programs, but no matter how that falls out, to really work on the UK's narrative of being a welcoming and attractive place to come. And of course, it has to work all the harder to make that case when the legal and regulatory frameworks that were provided by that programme are at the moment not in place as easily as it were. I think this is where, as we were saying earlier, the fact that, we're not scientists alone, we are part of a society, a national and international society, and this is how, to me, it's very important that we have a clear national narrative about how the value of the UK's scientific capability to all of our prosperity, and if that can become integrated into political language and discussion about our future, I think that might help to send a more positive signal to people like your friends.
I think it was great that we used to be the California of Europe, but obviously different political choices have been made. What I find really bizarre now is the contradiction in policy. On the one hand, wanting a tough immigration policy and demonstrating that, and on the other hand, claiming that we can be a science superpower when we are undermining our universities in this way.
Yes, at the back.
Hi, I'm Tom Addison. I'm the policy manager at the Physiological Society. I want to pick up on something that was said earlier about climate change as a good example of sort of interdisciplinary research. And Diane, I'm interested to get your thoughts, I think, specifically on this. The REF 2028 guidelines, or sort of early framing for what REF 2028 will look like, came out last week. And one of the things that we were disappointed to see was that the sort of lack of focus on how we can best reward interdisciplinary research. And climate change is a good example as any of why we ought to be rewarding interdisciplinary research. You mentioned the need for the sort of the model of research and publish as not being sufficient to really address those kind of macro problems that we have. So I wonder if the panel have any thoughts about what they'd like to, how they think we can use a policy lever like REF 2028 to better reward scientists which are working on big interdisciplinary projects with the social sciences, as much as other STEM subjects as well.
Johnathan spoke about this also, but I can start. The barriers seem to me not to be in terms of funding or in terms of interest among researchers, because there are always people who want to work on important problems and challenges. The university hurdles seem much more powerful to me, and I'm relatively new in the university sector. I've been an academic for 10 years and did many other things before. The incentives are to stick in your disciplinary silos, publish in your disciplinary journals. And it's very hard for me as a senior person bringing in research grants to say to young people, well, you should take these risks. This is really important, interesting work. By the way, as well as doing that, you've got to tick all the other boxes too, and make sure that you've got a career in a home department at some stage. So I think that's a system problem and a university problem. And, I wish the ref had been a little bit more powerful in that way.
I'm going to give a counter argument to that one, actually. And so I recruit to our department, and my recruitment decisions are driven by the way the ref assesses researchers. I need to recruit researchers who are going to be submittable to Unit of Assessment 10, which is the Mathematical Sciences panel. Now, I'm recruiting into the stats bit of the department, and lots of our researchers are naturally interdisciplinary. We do stats for something, but I need to make sure they have enough sufficiently mathematical research that they can go to Unit of Assessment 10. And I agree, I think there's a big gap here. I think the very strong disciplinary assessment panels and REF really drives narrowness of research focus. And I think a stronger, more trusted cross-panel assessments technique would be valuable, because it's there, but I don't trust it. I don't send any of my interdisciplinary work into the REF because I just do not trust that it will be suitably assessed. And I think a much stronger focus on that would be important. I think there's still scope to get that in there. And so let's work together to try and push it in.
No, I agree with that. I declare an interest is to work with the Physiological Society on interdisciplinary. But I think what we heard was that the incentives and the funding are actually quite well in place, but the reward mechanisms are perhaps lacking, and the confidence in those sort of assessment and evaluation mechanisms are lacking. So I hope that you'll be pushing at an open door, but I think it absolutely makes sense for the next REF agenda to better recognise and reward interdisciplinary research.
Good morning, everyone. I hope you're all happy and enjoying your time listening to these interesting comments. So I have 4 questions. Can I have 4 questions, each member of the panel? I'll give it a go and I'll keep it short. So, Sarah, the electrome. Can you enlighten us about the electrome? If you can't, then just ask me. Diane, science dilemmas, which is really interesting how you approach them. Mind control in today's society. How do you do defense on that? Johnathan? 4 bases. We've only got 4 bases in nature: guanine, cytosine, adenine, thymine, and then we've got uracil. Now we've got XNA, DNA, new nucleic bases. And what's your prognosis on that? And lastly, polymath. I love polymaths, and you appear to be one. So who's your favorite polymath of today, and where are they taking us?
Just explain the first thing you said to Sarah, electrome.
So the electrome is the electrical blueprint that makes your body the way it is. A famous scientist in this field today is Michael Levin, professor from Russia, working in America. Michael Levin, if you look it up. Electron. So it's bioelectricity, your bioelectric imprint, which if you take, for example, the leg of a newt and you put it where the arm is, the electrical biology of that will then change it to an arm. In other words, the leg will change to an arm.
Thank you.
So you have an electrical epigenome, which then controls
I'm
that.
conscious that we only have about 8 minutes left, so I'm going to pick one of your questions.
Okay.
David, would you like to answer the question about your favourite polymath?
So to avoid offending any of my esteemed colleagues in the scientific community by not listing them, I'm going to instead take an unknown polymath, Web Centre of the Unknown Soldier, and say that the new high school student who is interested in everything is the most important polymath of today. We need to inspire them for the future and make sure they're beneficial for everyone.
Okay. Very gentlemanly.
Hello, I'm Robert Campbell from St Mary's University. I'm going to begin by declaring a bias in the question. So I'm an educator. I lead a science education program at the university, and I also do research on interdisciplinarity and the role of interdisciplinarity within school curricula. And so I'd like to take us back to that conversation we had about interdisciplinarity. It strikes me that that's a conversation that we very frequently have within the science community. It's very accepted that actually we need to not only talk to the chemists, the biology, the physicists, but equally the mathematicians, the social scientists. That doesn't seem that controversial. And yet when I go to a different space of working in policy and education, that is incredibly controversial, and we need to be going more siloed. And you only need to look at the governmental policy to say maths to 18 is compulsory, and the drive to actually, so I work with chemistry teachers primarily, there is a drive to only have people with chemistry degrees teach chemistry, not actually have good teachers. So my question is, how do we actually utilize the energy in this room, the fact that we're modeling interdisciplinarity simply by the range of groups that are in this space, the frequency of mentioning interdisciplinarity, to actually empower us who work interdisciplinarity across fields in education, in science, and in economic policy to inform governmental policy more widely?
I'm really, I absolutely agree with you. I'm breaking my own guidelines. I don't really like personal anecdotes, but I can't help it because I've just been in my daughter's school yesterday talking about this exact thing. It's driving me mad. So I have a 13-year-old child who right now has to choose between computer science, Latin, art, music, drama, and something else I can't remember. And I think it's unforgivable to make them, that will tell you that a sixth of them, or 5/6 of them, won't do computer science beyond the age of 13. I'm personally very frustrated by this issue at the moment, but I agree with you in the round that you do get lots of children, as you said, your polymath example, and lots of children are enthused by the richness of subjects they study at school, and are boxed into having to go down one route and not another, with very little provision for them to retain skill and progress in those subjects that they can no longer continue. So I think that our school education systems do feel like they're ripe for revolution, really, that including the issue that you're talking about, which is that the schools continue to teach in very blocked silos. Perhaps some schools do some, an additional subject that's a bit broader, on top, but also they just seem that it seems that within 2 to 3 years they're going to have to transform teaching methodologies and so on to sort of keep up with the changes in the world around them. But it's enormously frustrating and very difficult, I think, then for people when they get into further or higher education and into the world of work to then be actually as capable at using all those different skills that they need to in 21st century careers.
Can I expand this a little bit? So the teachers need to be supported better. We underpay them and we overwork them. Without the inspiring teachers there to keep kids enthused, then we are cutting ourselves off at the source. Teachers are constantly faced with yet another initiative to improve things. The vast majority of teachers are there because they want to educate kids and they want to inspire kids, and a huge number of them leave the profession really quickly at primary and at secondary. And I don't think it's teachers that are insisting on keeping things now. I think it's the world they're faced with and to try and survive as a teacher, that means they don't have the energy to go wider. I think the best investment we can make as a country is to massively support teachers and make them feel valued much more than they are, and to support them to continually develop as individuals while being teachers.
Okay, so I'm afraid this is going to be our last question.
Thanks. Tanya Sheridan, Royal Society of Chemistry, and we've started to think about future skills needs, and I'm hearing a lot from this panel discussion, which has been really rich and brilliant. Thank you all ever so much. That skills is very important, and many important skills are in short supply, and yet having the right skilled people is necessary to drive economic development. So what would you like to see change in policy, in attitudes, in workforce development, particularly for skills for people in work in scientific and related sectors? Because probably 80% of the workforce in 2033 is already in the workforce now.
I mean, I can kick off. I think I would really like to see somehow embedding more of an entrepreneurial culture in our workforce. It's something actually that we've talked about a lot. I think people talk about, you know, we've got this entrepreneurial spiritual culture or mindset, but actually I think that's just sort of words that don't really have any substance behind them. I don't know how to make it more substantial, but I think it would be great if we were just able to encourage, you know, and maybe we need to embed, you know, in universities, linking the business schools with the actual sort of fundamental science schools, just to sort of give people an exposure to a more entrepreneurial.
I'd like to see more pathways. We've got quite rigid routes through the education system. You know, it's choosing your subject for GCSE and A-level, but also opportunities for adult education, more integration of FE and HE, more apprenticeships. Obviously, all very easy to state. I'm not quite sure why it's been so hard to do over the years, because they seem sensible consensus policies, but that would be my choice.
David?
So in the early days of Google, every employee got 1 day per week to develop skills or research or whatever they wanted to develop themselves and new products. That led to lots of products for Google, and it led to lots of very engaged and highly skilled individuals. I wondered if we could set up a conversation where lots of employers could be persuaded to do something similar, and civil service. Actually, in the civil service, for 1 day a week, everyone was out developing new things, learning new things, and upskilling themselves constantly. I think that would be a really interesting experiment for the country.
Thank you. And Sarah?
Thank you. So Tanya, thank you for your question, and I think it is worth paying credit to the Royal Society of Chemistry for all the work they've done on increasing skills in recent years. It's been terrific. The Campaign for Science and Engineering has just published a report called The Skills Opportunity, which does try and address the question that you asked, and I won't sort of try and go into too much detail, but I think, you know, being able to monitor skills gaps and needs and understand them is really important. I think, you know, quite a dynamic approach to thinking about those through people's careers is vital, and so this idea of upskilling and reskilling in the workplace is absolutely essential in our fast-moving, transforming economy. And support for employers. So that's, you know, a terrific idea, and that kind of opportunity for people to upskill in the workplace, but there does need to be support for employers and individuals to help them do that. And of course, we talked about immigration earlier, and I'd say that's an essential part as well. I would say for the one policy thing I would ask for is that we see now in this framework that I mentioned earlier, so the Department for Science, Innovation and Technology has its Science and Technology framework. People and skills is one of 10 things on that item. What I would like to see is that department using its power now, its Secretary of State cabinet level power, to really connect and coordinate with the Department for Education and other relevant departments to bring that kind of integrated view of skills provision across technical education, employer-led reskilling and upskilling, immigration from the Home Office, and further and higher education, into, you know, this challenge of how we provide for everybody, every person in the UK to benefit from and be part of a science positive, innovation positive.
Thank you. I'm afraid that's all we have time for. So if we could all thank our panel.
Thank you very much to the panel. That was great. Thank you for your time. We are always extremely lucky in the quality of speakers we have at these events, and that ranges from our politicians to our experts in the sector, but also, of course, to policy advisors and those in government who sit slightly on the other side of the fence, offering advice from the official perspective. We've been really lucky in the past to have engagement from the government chief scientific advisors over recent years. The role is incredibly important, as of course is the whole network of chief scientific advisors across departments. And I'm really thankful that today our new government chief scientific advisor, Professor Dame Angela McLean, has agreed to come and speak to us so soon after your appointment in April this year. Thank you very much.
Thank you so much for that kind introduction. So good morning, everyone. I am now 3 months into my role as Government Chief Scientific Advisor, so I think it's okay still to do a little bit of introduction of myself. I'm a mathematical biologist from Oxford, and before this current role, I was Chief Scientific Advisor in the Ministry of Defence. So in my role as Government Chief Scientist, I consult and collaborate with experts in academia, industry and government. And I do that so that I can provide the Prime Minister and the Cabinet with science advice that is relevant, accurate and robust. And so I'm particularly happy to be here today, since this audience covers precisely the kind of people I will strive to bring together in my role and through the work of my office. So this is an exciting time for science. In some sense, the case for its importance and application has been accepted, but I'm not in any way suggesting mission accomplished. The case for science must continue to be both made and also proven. But nevertheless, there is a clear consensus that we must, as a country, exploit research and development to deliver measurable societal and economic benefits for the people of the UK. And the structures of government have changed to reflect this central role for science. The Prime Minister has made the new Department for Science, Innovation and Technology, which is there to focus our minds on becoming the most innovative, science-driven economy in the world, a clear statement of intent. We have a Cabinet Committee dedicated to science, and that's chaired by the Prime Minister. And we have a Minister for Science, Innovation and Technology, as well as a Shadow Minister. And of course, it's an honour to share the same stage that they were both on earlier this morning. Sarah referred several times on the panel to the Science and Technology Framework. So this is the new, I think I can call it a strategy, even though we're all a bit allergic to the word strategies now. So this was the framework for science and technology that we published in March. And whilst we were working on it, we always used to call it 10 big things. I thought that was a great name myself, but it now has to be called the Science and Technology Framework. So why 10? It's because it contains 10 strands, 10 key things that underpin the whole system as an approach to supporting and harnessing UK strengths in science and technology. There are 10 ways to ensure that the brilliant ideas created in our labs get turned into great products and services that can generate prosperity and well-being and become the engine for growth that we know is possible. So what does this mean in practice? Well, since this event has been organised by the Royal Society of Biology, thank you, and I know many biologists are here, I'm also going to use engineering biology as an example of the challenges and opportunities for achieving growth through S&T. So engineering biology is also one of the 5 critical technologies that get name-checked in the S&T framework. So just to be clear what I mean by the term, engineering biology is the application of rigorous engineering principles to the process of taking designed biological components and turning them into solutions for the innovation problems we face today. So challenges that include energy, environment, food, healthcare, manufacturing, materials, just some of them. So in healthcare, we produce great life sciences R&D and boast a well-connected ecosystem of technical firms, suppliers, and specialist vendors, which has evolved to support the life sciences in health. and could also grow to support wider engineering biology applications. By our own international comparative analyses, we generate world-leading research in engineering biology. Between 2017 and 2022, this country ranked third in the world, behind China, behind the US, for research productivity. And actually, in that same time span, we were also good at spin-out. We ranked well for numbers of funded spin-outs. But we don't do so well at scale-up after the spin-out stage. And translation from R&D needs to be world-class right across this chain that goes from brilliant ideas through spin-out to scale-up, if we want to grow the sector and deliver the societal benefits that we know this technology can offer. So achieving this will need collaboration among academia, industry, finance, policymakers. And that's the point of the S&T framework that Sarah was referring to, is to try and coordinate the many little balls that we have to get settled into the puzzle that Diane so eloquently brought up as an analogy. So as an example of the kind of collaboration across many kinds of efforts that we need, I've recently been very conscious of the need for shared thinking in my work exploring regulatory opportunities in the life sciences, and that work included engineering biology. So that's why I recommended the creation of an engineering biology regulatory network to bring together expertise from across the many different regulators, because this is a very widely applied critical technology. So we're going to need timely, safe, coordinated regulation of emerging technologies like engineering biology, if we want them to drive innovation and growth in the way that we know we need them to. So turning to another thing that is on my mind, it's ensuring that we have a brilliant and diverse set of engineers and scientists working in and collaborating across the civil service. The Government Office of Science, that's my office, is pushing to increase the number of scientists in the civil service, so we have the skills needed to ask for the science in the right way, at the right time, and then use it effectively. We're actually on track to reach our target of 50% of fast streamers entering the civil service. So this is young people coming into the civil service, being people with STEM degrees. And do bear in mind that this percentage used to be just 10%. Just finally, I want to return to this recurring theme of collaboration across disciplines, across sectors, across government. I see great opportunities for much more of this in terms of the science that is done inside government. I quite often find myself explaining to my civil service colleagues that in the olden days, when I used to be a senior academic, I actually spent 60% or more of my time on other people's work. That would be reviewing grants, reviewing papers, time on panels, handing out grants and fellowships, time at conferences, talking about our work, or more importantly, probably listening to other people talk about their work. All of that work was about knowing what other people are doing. So why do we do that? We did it because we learned from each other. And that means the system as a whole can move much faster. And I think there is space for a lot more collaboration amongst Whitehall scientists, as well as, of course, as with scientists from right across our R&D system. So I am optimistic. Based on these first 3 months as chief scientist, I have great confidence that the UK science community, that is you, can together deliver on our stated ambition to harness the benefits of science and technology. But I am keen to hear your views from biologists, other scientists, policymakers, and people who actually have to make decisions. And therefore, I'm going to stop there to allow time for questions and discussion. So thank you for listening.
Thank you very much. That's a great introduction. So our caterers are very keen that we finish on time, but with that in mind, we still have some time for a few questions. So if you do have them, if you keep them short, that would be really helpful. Thank you very much. I'm going to try and do a few together. So the first one, gentleman down here in the front row.
I'm a member of both the Royal Society of Biology and the Royal Society of Chemistry. In terms of looking at the bigger picture, I feel a little depressed and concerned. Clearly, there's nobody in this room who would disagree that we have a great pool of talent and prospective talent in the UK, but we have done some dreadful things in the past. You know, austerity has debilitated our economy and destabilized our society. We've had Brexit, which has disconnected us from Europe, and the government has still yet to make up its mind about the Horizon programme. COVID seems to me to be a dismal exercise in not following the science, and to pick up on Stephen Metcalfe's, you know, advice does need to be followed. So where do we go from here in terms of you know, the direction of travel for the UK? And I presume that given that resources should be no problem, since we're advised by Sir Jacob Rees-Mogg that the tidal wave of Brexit benefits are hitting us with great force, that should not be a problem. But what is the progress for the UK from now on? Thank you.
You got a microphone there? Yeah, yeah.
Oh, thank you. I'm sorry you're depressed. I'm not depressed, and one of the reasons I'm not depressed is that we do have a plan. The Science and Technology Framework is a plan for how we will do a coordinated set of actions across 10, I think we call them strands now, rather than things, in order that we can harness, you know, basically the golden egg that comes from the goose, that is our base R&D. Much of it in our universities, but in other places too. And no, I don't think anybody would disagree that this country is still good at that. And of course, we must remain good at that. And as Diane raised in the panel session, we have this enduring problem that we don't seem to be terribly good at generating prosperity from it. And the point of the S&T framework, agreed quite widely, is to try and attack that toy and get all 10 silver balls into the puzzle, perhaps not all at once, but let's try and get them in one by one. And I don't view that as work for the next couple of years. I view that as probably something like 10 years work. I mean, that is a big change, but we do at least have a plan. And I think it was Sarah who made the point that it's fine to have a plan, but delivery is the really hard thing. And I am very committed to that delivery.
Thank you very much. We've got a question in the middle here and the gentleman here. We do 2 or 3 together, perhaps keep them short. So first. Great, thank you very much. And a question behind you.
Hello, Shemai. I'm Emma Weinel, a senior lecturer in neuroscience at Cardiff University. I'm here with the Biochemical Society today. Just a question about how we can better reward, recognise and value science across the devolved nations of the UK. So thank you, Diolch yn fawr.
Thank you very much. And just finally, gentleman here at the back, and then we'll take some answers.
Hi, I'm Richard Rees-Jones, the Royal Society of Biology. I'm a working consultant, so I go around a lot of labs a lot of times. And my question is quite simple. What on earth does the science graduate who comes out with a 2-2 do now? I'll tell you what they do. They don't work in labs anymore, they work in call centres. 5 years ago, when I used to go around labs, there'd be one PhD, and then there'd be a whole list of people with various qualifications of degrees doing good science work. Now I go to labs and I find a whole level of PhDs, and one myself, so I can't really complain that. A whole level of PhDs doing the work that those used to do, and they're all in call centres. Okay. And we need that powerhouse back in the lab. We don't need them in call centres.
Great inflation type question. Are you social?
How to help shape the S&T framework, get involved. So there it is at the moment as a plan, and it needs delivering, and that's a huge amount of work. But I mean, do understand that we're talking about delivery now. So we don't really want to reopen the question of what is the strategy. We want to open the question of how do we go about delivering this right across government. And that is, that's quite a heavy burden, which is held by DCID. Not that they have to do it all, but they have to coordinate that delivery across government. One of the ways people who are interested in getting involved would be to go find out about different science advisory councils that many departments have. So most government departments have a mechanism for reaching out for external science advice. And I can tell you, I've been doing that for some years now, in some decades, and I will admit that most of the people I hang out with were there when I started. So there was a real problem actually about diversity of seniority, should we say, because I don't know if I'm allowed to say age. We definitely need many more young people to get involved in that whole effort. And there was a question about how would that be recognised. It's not a hideous amount of effort, I would say. So it'll be something like 4 meetings a year and some work in between. It is super interesting work. And it's mostly not going to be about your own personal expertise. So my personal expertise is infectious disease modelling. Well, I can tell you that for about 40 years, I did advise the government there was nothing to do with infectious disease modelling. It was mostly, frankly, what would seem to most scientists, natural scientists, or social scientists, would feel fairly common sense-ish, actually. Not because civil servants don't have common sense, but because it's always useful to have outsiders come and ask you sort of plain English, dead sensible questions. So that's the one I would recommend, because that's the one I know. There are, of course, lots of other ways too, aren't there? There's the select committees, need clerks, there's all the work that Post does. So I would say get stuck in, get involved. Certainly my experience has been that that's very rewarding and interesting work. Reward and recognise devolved science, absolutely. I mean, our devolved science is super powerful. My way of doing that is to make sure that the chief scientific advisors from the devolved administrations are part of my CSA's network, and I can tell you that's actually rather a ferociously guarded role. So that network's about 20 people, and I can tell you I have a queue of about another 20 people who keep banging on the door saying, please can I join? And rather cruelly, I keep saying no. 20 people is about as many as we can manage a proper network. You'll have to make yourselves into some kind of network of networks, but rest assured the DAs are staying on there. The science grads with a 2-2, I'm not sure I really understood this question. If it's about salaries, then yes, we have a real problem. I think there are things we will try to do about science salaries, but that's a big old job. I mean, that would be government science salaries. That is a big old job, so I'm not going to make any promises about it. Thank you.
Thank you very much. Okay, so we perhaps have a chance for just one last quick question. Yes, you were first.
Yeah, Katie from UK Central Ecology and Hydrology. We've talked a lot about skills and the fact that we are missing a lot of skills, and that's a really important thing for progress in the future. I'd say that one of the potential reasons that this could be happening is because of a lack of equity, diversity and inclusivity in the science area. What can the Government Office for Science do, or what is it going to do to try and improve that at all sort of levels of education, higher education, and in the scientific workforce to try and improve the skills? Because I think it's quite widely accepted that greater diversity in ethnicity, for example, genders, etc., can only improve science.
Thank you, great question. Well, first of all, I'd say as the first woman who holds this role as Government Chief Scientific Advisor, I do feel pretty strongly that science and technology is for everybody. And that includes women as well as men, and people from all ethnic backgrounds, and people from all sorts of educational backgrounds too. I'm going to Big Bang Fair later on this week up in Birmingham, where I'm hoping I get to do very serious work, meeting young people and interacting with the exhibits there. And that will be, I mean, that's a place where I will very much be promoting the idea that science is a really interesting job and everybody should think about becoming a scientist.
Thank you very much. So I don't know if you're able to stay for a little bit afterwards for some food. So there's an opportunity now for some networking. We have food just through here. So please take the opportunity to have something to eat, to talk to some of our speakers today, to talk amongst yourselves and to network. As is the case with a lot of parliamentary-based activity, the sessions of Parliament do tend to interfere very conveniently with events such as this. But today actually hasn't been too bad. But I think we are missing our final speaker to do a vote of thanks. Is he here? He's here. Ah, fantastic. That's good. He's arrived. In which case, that's perfect timing. As many of you will know, Stephen Benn has been involved in Links Day right from the inception. Very much the grandfather of this event. I'd like to invite you to do a vote of thanks, and of course, in his new position on the House of Lords Science and Technology Select Committee, the Viscount Stansgate.
Well, good morning to everybody. It's my job to do a vote of thanks. I'd like to begin with Dame Angela. You've got a very important job, and I hope everybody in the room is very pleased that you are surrounded by the organizational structure to which you referred, which in my view is going to make your job easier, and some of your predecessors have not had the advantages that you've had in doing so. On the other hand, as you look ahead to a career as Chief Scientific Advisor in the years ahead, who knows what's going to happen? Events, dear boy, events is what's going to happen. Now, welcome to the Attlee Suite. It's misnamed. It's the Attlee Sauna. And when they designed this building, you may not know this, but it was in the days when people were worried about bomb attacks. It was designed to be bomb-proof, which is why the windows here can't be opened. And then some genius of an architect or a planner, and I'm sure his or her mum is very proud of their achievements, built this room over the kitchen, which is below us, which is why the hot air tends to rise. And having been in this room over many, many years for Links Days, it's exactly the same every year. Now, as I said, I want to say thanks to everybody. First of all, can I begin with you, the audience? A lot of you come from the list of organizations you can see on the screen. And that is the real strength of this event, as it has become, is the fact that there are so many different scientific societies that come together to make an event like this possible, because none of them individually could produce what you have seen today. And that's a very important point. I wouldn't be the first science minister who probably looks at this, or indeed the first chief scientific advisor who looks at that list, and there's many more still to come, and thinks, why there's so many? But nevertheless, it's important to work together, and today shows it. Can I also thank the speakers, beginning with Stephen, a colleague since 2010 and your first election and arrival on the Science and Technology Select Committee, and also George and Chi. I suppose I can now call you parliamentary colleagues. But the fact is that the science community is very well served by having people like you at the heart of the business of Parliament and science. Now, the speakers, especially those on the panel, I'm sorry I didn't hear all of you, or all of it, because in fact I went briefly to a meeting of the Science and Technology Select Committee in the House of Lords, of which I've recently been made a member, and we were discussing our future programme. But I shall not tell you a word about what that is. You're not supposed to reveal the contents of select committee reports before they're published, in case any of you noticed. But I gather that Sarah Main, if I may single her out, mentioned the fact that I think it was 10 years ago this month that you appeared on the panel in your capacity as chair, chief executive of CASE, and I think you've done a wonderful job ever since then. And I look back and it's amazing how many years ago it was. I'd also like to thank all the staff who've made it possible, because it's not nothing to produce an event like this. I'm glad to say it's online, in the sense that I'm glad that we're here in person and it's available online. And I think, having gone through the pandemic when we did in fact do it online, it wasn't remotely as good as doing it this way, with access for people who can't be with us today in person and can relax in air-conditioned surroundings while they watch the rest of us sweat. So I would like to thank the staff very much, and I'd also like to thank the Royal Society of Biology and Mark Downs for the leadership that the Society has shown in bringing together the science community to make today possible. And that is really very, very important. Now, I'm here for a vote of thanks, but I know the real reason I've been invited. I've been invited as a parent. By the way, I take exception to the fact that Mark said grandparent. But, you know, I organised the very first Parliamentary Links Day in 1988 in a room that I doubt if any of you here have even heard of. Has anyone heard of the Harcourt Room? Well, nevertheless, that's where it was. And when I look at the group in front of me here, boy, you look nothing like the group that was there 35 years ago. So all I can say is immensely better now in every possible respect. We didn't have a chief scientific advisor 35 years ago, not in that way that we do now. There were very few members of parliament who seem to take an interest in science, whereas you speak to any member now and ask them about artificial intelligence, and they will know immediately how important this is and what the potential is for the future. And I can tell you that a number of select committees are fighting amongst themselves to do the next inquiry on artificial intelligence, and it may well be that you will be called to give evidence to a number of them. Anyway, just to say that it has changed a lot, and therefore as a parent, proud parent, if you invite me back in 10 or 20 years, I'll be a grandparent, if you like, in the year 2041, but not yet. As a parent, I'd like to say thank you all for coming. And now the food is behind those doors. So thank you again and goodbye.